Our final speaker for this session is Daniel O'Connor. Dan serves as Vice President of Engineering at Schirmer Engineering Corporation and is a colleague of mine. I have the pleasure of working with Dan every day, mostly because he helps me look good anyway. Ladies and gentlemen, Dan O'Connor.
Thanks, boss. Greetings this afternoon. For this final presentation for this session, I'm going to talk to you about building facades or fire safety facade. And there's definitely a question here. And the design of facades for buildings that we've seen this week can be very complex. There's a lot of very interesting facade designs I've seen in the presentations this week with these twisted and torso buildings and circular buildings and overlapping designs and buildings with photovoltaic panels on the exterior and buildings being suggested to be built with facades that use textile materials. So I think there's a lot of interesting things coming out there, but what I wanted to do today was give you a presentation in a historical perspective to illustrate some facts, and then at the end of the presentation conclude with what I think are some risk considerations that may need to be reviewed on any given building in the future. And some of these things I'll talk about fit into our previous presentations today. So here we are. This is, we can see how the facade, along with the architectural structure, really works to distinguish the building. Here we can see, these are some buildings in Chicago. The building on the right is the John Hancock building, 100-story building in Chicago, built in the 70s. And over to the left, we can see the Sears Tower, which was the tallest building in the world up to the time of the Petronas Towers. So definitely we can see how the facade really defines and brings a character to all these buildings. And we're going to talk a little bit later on about a fire that occurred in the John Hancock building. But one of the things that distinguishes some of these buildings that were built during the early 70s is that for the most part, these super tall buildings that were coming online in the U.S., including the World Trade Center towers, were being built as non-sprinkler buildings. In the case of the Sears Tower, though, something that I look back and I see as being very relevant today and a very important decision was the fact that Chet Schirmer was able to convince Sears Roebuck and Company and SOM that Sears Tower should be built with a complete and full sprinkler system, including systems of water supply tanks and automatic fire pumps. Okay, so that was somewhat a unique and distinguishing thing to happen for a building of this height in the 70s. So there is a dual meaning here to the title of my presentation today. Again, here we can see some facades from example buildings in Chicago. On the right is what is now called the Aon building, used to be called the Amico building. And we can see here on the left in the insert the Trump Tower with a glass curtain wall design that has been, is nearing completion next year. Now, the Aon building, when this building was built, it included the original the original curtain wall design here was done with Carrara marble. And one of the problems with the Carrara marble in that facade is that it did not like the harsh winters of Chicago. So immediately after a number of years, they started seeing failures in the marble facade. Cracking, they had to put steel straps on the building to hold the facade in place. It was around 1990 to 92 they did a complete renovation of the facade, removing the Carrera marble and replacing it with North Carolina granite. Now, in doing that, one of the things that was important for that project was to take a detailed look at the cavities that lie behind the granite structure, the granite covering. There's cavities and channels that would pose and present cavities for fire to spread should they break out through the window and perhaps melt the aluminum mullions, communicating into that space and channels that exist behind the granite panels. So these facades do pose a somewhat of a concern, even though they do add to the character and beauty of all these buildings. Okay. Now, one of the other secondary meanings of facade here is to have a false, superficial, or artificial appearance or effect here. And this is a fire that occurred in 2004 in Caracas, Venezuela. This is one of the tallest buildings in Caracas, if not, I believe, maybe the tallest. And as you can see here, if you take a look at this, this facade is not acting in a green manner here. So I'm sure the steel, again, as we heard in some presentations, is recyclable, but certainly this type of event is not what we consider a green and sustainable event. So let's talk a little bit about what how are the mechanisms working that contribute to fire spread on the facade. So we have here, you can see the yellow square represents basically what the intent is of the International Building Code and the NFPA 5000 code. And what is intended here is that there should be no passage of flame or gases between the slab edge and the curtain wall assembly. And that is the gap here represented by the yellow box here. So what we're trying to do is prevent the floor-to-floor passage here of fire through here, and we want that yellow box to be able to resist the fire. If it doesn't, we're going to have a situation where fire would spread into the floor above, and this is certainly what the codes intend to prohibit in sprinkler buildings. Now, there is a bit of confusion here that occurs in terms of how these spandrel sections, and this is just a very typical generic type spandrel section, is developed. The testing procedures for curtain wall assemblies have to be robust enough so that in the test procedure we can be sure that the material put in the gap between the curtain wall assembly and the slab edge will survive the test, because the test is trying to show that that protection in the gap will last for a time period equal to the fire resistance of the floor. So what can happen, however, though, is the spandrel assembly can be attacked by the fire, be deteriorated, and the flame and passage of gases can occur even around the protection we have into the gap into the upper floor. Okay? This is something that the codes for a sprinkler building, under sprinkler building exceptions, would be allowed. This kind of condition would be allowed. Now, some of this might fit back into Bob Solomon's earlier presentation on enhancements. And one of the things to consider for your building, and if you're looking at enhancements for your building, do you want to allow this kind of condition to occur? Perhaps, perhaps not. And there may be other alternative ways to look at this. The other way that fire can spread is through the mechanism what we call flame leap. And basically, the mechanism of flame leap involves the compartment fire breaking out the glass and attacking the spandrel panel and the glass above, and radiant ignition or flame passage occurring then into the floor above. So here, the concept of flame leap is definitely something that's possible. We know it can happen. One of the things that can affect how the flames project and look onto the side of the building are the physical projections of the facade. Here is just a couple shots from a CFD analysis that show on the left-hand side how the flame can attach itself alongside the building as it projects upward. On the right-hand side, we can see that using approximately a 1-foot projection, we can make that flame stand off from the facade and not lick up on the glass or spandrel panel above. So these kind of things can have an impact. Of course, this is an on-wind condition. The wind conditions can certainly have a much more significant impact. But let's take a look at some major events that have occurred over the years. This is a slide that compares a number of significant fires that have occurred over the years. And all these fires, it was observed and attributed that flame was spreading and leaping along the exterior facade of the building. So we have 10 examples here. Over on the far left was the Andreas building in Sao Paulo, Brazil, where the fire spread basically from the 4th story up to the 31st floor. And next to that is the John Hancock building, which in 1973 had a fire on the 95th floor and spread approximately 3 floors along the glass facade. Now, what's interesting about the Hancock building in Chicago is that incident is that although that was a non-sprinkler building at the time, the fire department had very good access to the building and actually was able to get to the 95th floor in a 45-second elevator ride. So we can see the importance of elevators not only from the standpoint today of exiting, but from the standpoint of getting our emergency responders up in the building to attack these type of incidents. The third building in from the left, the Joelma building, was a very serious fire that resulted in 179 deaths. Many of these people died on the roof. 40 people leaped to their deaths, and another 46 people, I believe, were found dead inside the stairwells. So the Joelma building was another significant event in Brazil. As we move through here, we then see the Westvaco office building in New York, and that building can be characterized as being controlled because that building's floor plate was split into 4 sections by 1-hour partitions. So even though there was a very large fire department response to that fire, the 1-hour partitions and compartmentation features helped to limit that fire from getting out of control and spreading further up the exterior facade of the building. We can then see here too in the Las Vegas Hilton fire in 1981. This was an incident where the fire spread, I believe, about, what do my notes tell me? About 20-some floors in about 20 or 25 minutes, okay? So there's another, just shows you the characteristics of how these fires can move along the facade of the building. The first Interstate back in one Meridan Plaza, we'll talk about a little more. Then there were some other fires of significance. On the far right, the Park Central building in Venezuela, and we'll talk about that a little bit more too. If we go and we look at some of the curtain wall designs involved in these serious fires, the 2 in Brazil and the Las Vegas Hilton here, you can see here in the diagrams that there really was no curtain wall gap here. The floor slabs extended beyond the line of the facade, and in the case of the Joelma building, extended out almost 3 feet or a meter. In the case of the Andreas building, which had 28 floors of exterior fire spread, we had the floor slab continuous to an exterior concrete edge beam here. And then finally, the Las Vegas Hilton, with 23 floors of vertical fire spread, again had the concrete floor slab extend out beyond 1/4 inch plate glass. So what's important to recognize about these incidents is that the fire spread can very certainly occur. We don't need to have a curtain wall design where we have gap and we're trying to stuff materials in a gap. These three incidents illustrate that it's definitely possible for flame to exhibit itself out the window and ignite the combustibles on the floors above and spread quickly from floor to floor. And here we can see just a picture of somebody who sought refuge on the Joelma building on that 3-foot ledge became an area of refuge for that person. One of the things that are obvious when we look at many of these large-scale events was that there was an extreme fire department response needed to attack these incidents. In the case of the First Interstate Bank, the fire in Los Angeles burned for 3.5 hours. They were on the verge of giving up, the fire department was on the verge of giving up and abandoning the scene. They made one last attempt to get to the floor above the fire, and they were able to successfully stop it from further progressing up the building. But you can look here and see that we had 64 fire companies involved and 383 firefighters, okay? That is a huge response. The One Meridan Plaza, which is a picture of One Meridan Plaza during its fire event, this fire burned for 18 hours through 8 floors of the building. There were 3 firefighter deaths and 24 injuries. 51 engine companies and over 300 firefighters were required to respond to that incident. Now, what was unique about that incident is after 11 hours of their firefighting efforts, the fire department made the critical decision to abandon their efforts in that building because of structural risks that they were concerned about and collapse. So you can see here that extreme fire department response can and is needed if you have these kind of catastrophic events occurring. Venezuela's tallest building here, the Park Central, built in 1970, had a fire in 2004. What's significant about this fire is that this fire, this building, when it was built with state-of-the-art features for the time. It was a fully sprinklered building, and it was built with what they called on-off sprinklers, a type of sprinkler that turns itself off if the fire dies out. Well, they had problems in how they maintain the on-off sprinklers in the building, and over the years, rather than trying to fix it, somebody made the decision that let's just shut the sprinkler systems off. Well, this fire burned for 17 hours, and again, after about 11 or 12 hours, the firefighter abandoned their efforts in this building for fear of structural collapse. Again, you can see how serious a fire this was in the photographs. So let's talk a little bit, as I mentioned earlier, the fact that it was Sears Tower distinguished itself by being sprinklered when it was initially constructed. And we have some sprinkler capabilities to talk about here. In the One Meridan Plaza, that building was fully sprinklered at the 30th floor. For some reason, they were beginning to retrofit sprinklers, and it happened first at the 30th floor. The only thing that saved that building was 10 sprinklers on that floor operated to put out the fire as it penetrated up into the 30th floor. Another solution that has been looked at was done by LPC Laboratories in Bournemouth, England. And what they did is they lined up some sprinklers on a glass facade and only along the facade. It wasn't an installation of sprinklers throughout the compartment. And they looked at the temperatures that would result in the compartment and then the temperatures that would result at the window without sprinklers. When they tested the same situation with sprinklers at the window line, we could see a reduction in the fire gases in the compartment, but a very significant reduction in the temperatures on the glass. And what was important about this is this helped delay the breakage of the glass for 20 minutes here. So there is some data here to suggest that just a single line of sprinklers can be useful on the facade in a building and might be some type of enhancement to consider in the future. One of the other things to consider is that in many complex assemblies that are built up, and this is not unlike a number of facades that I've seen presented this week here, where we have steel members, aluminum members, perhaps mineral wheels stuffed in the gap. The problem with these type of composite or complex assemblies is all these things have different rates of expansion, and all the materials work differently. And the only way to really understand and know how this facade will perform is to do some full-scale testing. We can complicate the matter by putting on a second facade, and some of what we now see is these expanded use of double curtain wall designs. Now, imagine that we can have flame leaping out a window if we had an unsprinkled situation, but with the double curtain wall design, all we do is help to close in that flame and keep it close in the facade. So there's some greater risk with these type of curtain wall designs. One of the things that's interesting too that I'm involved with right now is for the Chicago Spire development. Typically, it's easy to protect a perimeter gap if you have a curtain wall that is just flat, and we can fill that gap perhaps with just mineral wool. Because of the curvilinear nature of the exterior curtain wall, the spire will have a curtain wall panel, metal panel that will be twisting and turning as it moves linearly along the side of the building. So it'll be as angled out in some cases and angled back in other cases. This is a difficult situation to deal with, and we're actually looking at some unique solutions to protect this gap because it's difficult to maintain mineral wool in the gap. And we know this from having done mock-up construction. So anyways, to conclude here today, one of the most important things that our super tall high-rise buildings need are automatic sprinkler systems that are, one, reliable, and then we continue to maintain them in operable condition. Certainly the fire in Venezuela was a situation where they had a fully sprinkled building, but they shut it off, and that would have made a large difference. Fire department and brigade response capabilities are an important thing to recognize here. I'm not quite sure of what the fire department response capabilities are like here in Dubai, but you can see even with strong, capable, and practiced fire departments in the U.S. that they had great difficulty in addressing some of those catastrophic fire events. Okay, building height. Building height, of course, can be a concern. The taller our buildings get, the more time it takes for our fire brigade to get up in the building. It takes more time for people to get down, and things can transpire. Time is a critical thing. So building height is a risk factor. Building occupancy considerations become important. In the case of an office building, certainly we can recognize that people are awake, alert, and probably can get into the stairways and down the stairways fairly efficiently. However, if we have a hospital situation where people are bedridden and can't really be moved easily, there may be additional considerations there in making sure that your curtain wall or facade design provides an additional level of protection in the event, the rare event of a sprinkler failure. Building compartmentation features can be important in looking in holistically at the curtain wall design for building, because as we're sitting in this hotel, if we were to have fire spreading up the facade from one room to another room, the compartmentation features of the rooms themselves would kind of belay and prevent continuing spread into the adjacent rooms and combustibles that would allow that flame to continue to extend. The building evacuation strategies can be an important risk factor. Simon talked about the single stair buildings and how they use a defend in place. Well, if in a defend in place type occupancy, you're really trying to truly defend in place, maybe we have to think about how we design the curtain wall. And a couple other things here is the fire hazard and fuel loads will affect the flame projection out, and security threat assessments for the building can be unique situations that may need to come under consideration when making decisions on how to deal with your curtain wall. So in summary, this week we've seen a lot of unique facades, and I see these facades that are turning, they're tilted over each other, the floor slabs. I don't know that we know enough about how these type of facades will perform. There's a lot of IGUs, insulated glass units. We don't know how they perform. I think we're in a period of trying to learn more about facade performance from the standpoint of fire. Thank you.